In December 1998, a young cosmologist at MIT opened his email and felt the blood drain out of his face. The message was from a senior physicist, a famous one, the kind of man who quietly decides whose career lives and whose career dies. And it was a warning. Your crazy papers, it said, are doing you no good. If you don't separate this nonsense from your serious work, better yet, abandon it entirely, take it down to the pub where it belongs, you are going to destroy your future. The young man's name was Max Tegmark, and the idea that one of the most powerful people in his field thought should bury him, the idea so dangerous it arrived wrapped in a threat, was this: that the universe is not described by mathematics, that the universe is mathematics, that you and the chair you are sitting in, and the light reaching your eyes at this exact second, are not made of some kind of stuff that obeys equations. You are made of the equations. I know how that sounds. It sounds like a stoned undergraduate at 3 a.m. But I want to make you a promise before we begin, because I think you deserve to be warned the same way Tegmark was warned. By the end of this, you are going to understand why some of the most rigorous, Nobel-decorated minds in the history of science have arrived. Reluctantly, sometimes fighting it the whole way, sometimes against their own stated wishes, at a conclusion that should be impossible to take seriously. And you are going to find it very, very hard to take unseriously. Because there is a mystery sitting in the exact center of what we proudly call real science. It has gone unsolved for more than 2,000 years. The smartest people who have ever lived have looked straight at it and admitted, openly, that they have no idea what they are looking at. And once you see it, you can't unsee it. It will be there the next time you drop your keys. It will be there in your kids' homework. The foundation of all modern science, it turns out, might be real magic. Let me show you. In 1966, the neurologist Oliver Sacks met two 26-year-old twins, John and Michael. The hospital had filed them under just about every label it owned: psychotic, autistic, severely impaired. Their measured IQ was around 60. They could not reliably add two numbers. Multiplication meant nothing to them at all. The operation simply did not exist in their minds. They were, in the cruel arithmetic of the institution, calculators who could not calculate. One day, a box of matches tipped off their table and scattered across the floor. And both twins instantly, in the very same breath, said the same number: 111. Sacks knelt down and counted them. There were 111 matches. He asked how they could possibly have counted them that fast, and the twins gave him a look. Sacks said it was the look you might give a blind man who had asked you to describe the color of the sky. And they told him they hadn't counted anything. They had simply seen that there were 111. Let that sit for a second. Hold it, because here is where it gets strange. These two men who could not divide one number by another would sit together in a quiet corner and play a game. They traded numbers, 6-digit numbers, back and forth, slowly, smiling, the way two old men might pass a bottle of very good wine between them and savor each mouthful. Sacks couldn't work out what the game was, so one night he wrote the numbers down and went home and checked them against his tables. Every single one was a prime. A prime number, divisible by nothing but itself and 1. The twins, who could not perform division, were swapping primes for fun. So Sacks did something wonderful. He came back the next day, sat down with them, and into a pause in their game he gently offered a number of his own. An 8-digit prime. There was a long silence. And then both twins smiled, the same smile they gave each other, because they had checked it somehow and found it good. They let him into the game. Over the following days, the numbers grew. 9 digits, 10, 12, 20. Numbers so large that Sachs could no longer verify them at all. Numbers that in the 1960s only the most powerful computers on Earth could test. Numbers for which, and I want you to really hear this, there exists no formula, no shortcut, no direct method of calculation whatsoever. You cannot derive these primes. You can only find them. And these two men, who could not add, were finding them in their heads for fun and recognizing each other's finds. Sachs's conclusion, and I'll paraphrase rather than dress it up, was that the twins were not calculating anything. They had direct access to the landscape of numbers. They could see it, the way you and I look up on a clear night and take in the whole sky at a glance without counting a single star. The twins looked into arithmetic and saw a structure that was already there, glittering, hiding in plain sight from the rest of us. So hold that thought, because we are going to need it. Two men who couldn't add could perceive a hidden order in numbers, an order that turns out to be real, and that is woven so deeply into the fabric of the universe that we are about to find the exact same order in a falling rock, in your own face, in a piece of music, and eventually in the interior of a black hole. Now, the twins are exotic. Easy to file them away as a curiosity, a glitch, a sad and beautiful exception. But the uncanny thing is that the same order they could see is hiding in things you have watched your entire life and never once questioned. Drop something. Anything. A rock, a coin, your phone. Actually, don't drop your phone. In the first second of its fall, it covers a certain distance. Call it 1 unit. In the second second, it covers 3 units. In the third, 5. Then 7. Then 9. The odd numbers marching out in perfect order, forever, at any time interval you care to pick. Galileo noticed this 400 years ago, and it should still stop you cold. A falling object behaves as though the universe knows the difference between odd and even. Why on earth should reality care about the parity of integers? Why should a rock have any opinion at all about number theory? It doesn't know it's falling. It doesn't know anything. And yet it obeys, to the decimal, a rule written in the language of the very thing the twins could see. Or look at a face. You can't say why one face stops you and another doesn't. You couldn't write the formula if your life depended on it. But some part of you already has. Your brain ran the calculation, the ratios, the proportions, the symmetries, the distances between features. And it finished long before you were conscious of looking. We have a word for the output of that hidden arithmetic. We call it attraction. The input was numbers. Or listen to music. Pythagoras, 25 centuries ago, found that the intervals that move us, the ones underneath nearly all the classical, folk, and pop music ever written, are simple whole number ratios of a vibrating string. 2 to 1, 3 to 2, 4 to 3. The pleasure that runs through you when you hear a perfect fifth resolve is, in Leibniz's gorgeous phrase, unconscious arithmetic, the soul counting without knowing that it counts.
Schopenhauer went even further and said music is the most direct expression of the deepest layer of reality there is, deeper than the world we see. And here is the detail that should genuinely raise the hair on the back of your neck.
Savants like the twins, the number prodigies, are very often musical prodigies too. The same wiring, as though music and mathematics are not two subjects at all, but two windows looking into the same hidden room. Now you have to understand how seriously the ancients took this. To Pythagoras and the secret brotherhood that gathered around him, number wasn't a tool for measuring the world. Number was the world, the literal substance of reality, more real than rock or water or flesh. Everything, they believed, was whole numbers and the ratios between them. It was practically a religion. And then one of their own, by tradition a man named Hippasus, proved something monstrous. He proved that some lengths cannot be written as a ratio of whole numbers at all.
Take a perfectly ordinary square and draw the diagonal across it, corner to corner. And the length of that line is a number that runs on forever, with no pattern, and can never, ever be captured as one whole number divided by another. The square root of 2. An irrational number, hiding inside the most innocent shape imaginable. The story goes, and we will never know how much of it is legend, that this discovery so horrified the Brotherhood, so threatened everything they had built their lives on, that they took Hippasus out onto the open sea and drowned him. A man, possibly murdered, for finding a crack in the floor of reality. That is how high the stakes felt, even then, when somebody glimpsed the real structure underneath the world. People do not drown each other over a mere tool. So it isn't just two strange twins in a hospital. The order is everywhere. In the rock, in the face, in the song. The only genuinely strange thing is that almost nobody ever stops to ask the obvious question. So let's be the ones who ask it.
In 1960, a Hungarian physicist named Eugene Wigner, a man who would win the Nobel Prize, wrote a short essay with a title that became famous among people who think about these things for a living. He called it The Unreasonable Effectiveness of Mathematics in the Natural Sciences. And his point, paraphrased, was devastating in its simplicity. There is, he said, no rational explanation for why mathematics describes the physical world. None. The fit between the symbols we scribble and the universe we live in is not a tidy bit of bookkeeping. It is something close to a miracle. A gift, Wigner wrote, that we neither understand nor deserve. Now think for a moment about how the single greatest theory in the history of our species was actually built. Einstein did not look through a telescope. He did not run an experiment.
He sat in a room for the better part of a decade, and he drew symbols on paper. To most of the human species, those symbols are runes, meaningless alien marks. And out of those marks fell the curvature of space-time, the bending of starlight around the sun, the slowing down of time itself near a massive body. He wrote down the marks first. Reality confirmed them afterward. We call this activity mathematics, and we do it with a straight face, as though we understand what we are doing. And the people who understand math best in all the world, the mathematicians themselves, will tell you, if you ask them honestly, that they do not know what mathematics fundamentally is. And I need to plant one more idea here, because it is going to become a load-bearing wall later. Galileo said it plainly 4 centuries ago. The universe, he wrote, is a great book lying open in front of us, but we cannot read a word of it until we learn the language it is written in. And that language, he said, is mathematics. Its letters, triangles, and circles, and other geometric figures. Not a metaphor, a claim about what the world is made of. Centuries later, the physicist James Jeans looked at the new quantum picture and said the universe was beginning to look less like a great machine and more like a great thought. That it looked, in fact, as though it had been designed by a pure mathematician. And in our own time, the Nobel laureate Frank Wilczek described the single strangest moment of his life. He had spent days filling pages with abstract symbols, working out what his theory predicted. Then he went down to the laboratory and watched the detector, and the tracks the real particles carved through real matter were the exact shapes his symbols had described.
And he said he felt, just for an instant, something close to mystical terror. The realization that his scribbles on paper and the events out there in the physical world were not two things in agreement. They were the same thing. The marks on the page were the particles. He never quite got over it. So hold this. You do not get to buy a physics theory a la carte. You can't keep the parts you like and send the rest back. General relativity describes the orbit of Mercury beautifully, down to a tiny wobble that had baffled astronomers for decades. Wonderful. But the very same equations, the same rigid math, force black holes into existence whether you want them or not. Einstein himself hated black holes and spent years trying to argue them away. He failed. The math wouldn't let him. The rule is brutal, and it is simple. If the mathematics is right about the things you can check, you are obligated to take seriously the things you cannot. Remember that.
We are going to need it when the conclusions get hard to swallow. And now the story that, for me, turns all of this from a puzzle into something closer to vertigo. In 1913, a Cambridge mathematician named G.H. Hardy received a package in the post. It came from Madras in colonial India, from a poor, self-taught clerk with no university education, a man who had never met a serious mathematician in his life. Inside were pages and pages of formulas. Hardy's first instinct, reasonably, was that it was a hoax, some crank or fraud. Then he sat down with his colleague Littlewood, and they actually read the thing. Some of the formulas they recognized. Some of them they had never seen before in their lives. And those, Hardy said, I'll paraphrase him because the sentiment matters more than the wording, those had to be true, because no human being would have the imagination to invent them if they were false. The clerk's name was Srinivasa Ramanujan. In 32 years of life, much of it spent sick and poor, he produced very nearly 4,000 mathematical formulas. Most of them came with no proof, no working, no logical steps laid out between the question and the answer. They simply arrived, whole. And when people asked him where they came from, he told them with complete sincerity that they were not his. He said a goddess of his family wrote them on his tongue while he slept, and that each morning he woke and copied down what she had given him in the night. He said, and this line is worth getting exactly right, so I'll be careful, that an equation meant nothing to him unless it expressed a thought of God. You can call that a charming delusion. A lot of people did. But here is the detail that drags this story out of the sad genius biopic and into this video. Ramanujan's formulas are used today in string theory. They are used in the study of black holes. And when Ramanujan was alive, scribbling in a rented room in a country half a world away from the cutting edge of physics, those things did not exist. There was no string theory. There was no concept of a black hole.
the questions his mathematics answers had not yet been asked by anyone, anywhere on Earth. Somehow, dreaming, with no contact at all with the deepest machinery of physical reality, a clerk reached in and pulled out blueprints for a kind of universe that physics would not even imagine for another 50 years. So how is that possible? How does a mind with no connection whatsoever to reality's hidden architecture reach in and lift out its design? And there is a bitter little joke folded into the very same story because of who Hardy was. Hardy was proud, fiercely, almost defiantly proud, that his branch of pure mathematics was useless.
He wrote a whole book about it near the end of his life, in which he congratulated himself that nothing he had ever done had the slightest practical application. That his work was pure and clean precisely because the grubby real world could never get its hands on it. And reality, it seems, has a sense of humor. One of the theorems Hardy tossed off almost as an afterthought turned out to be the foundation of a law in population genetics, the Hardy-Weinberg law, that biologists still teach today. The man who staked his pride on being useless accidentally wrote part of the rulebook for evolution. You cannot keep mathematics in the cupboard marked abstract. Reality keeps reaching in and using it, whether you offer it or not. And if that question is starting to get under your skin a little, if this is the kind of thing that you suspect might keep you up tonight, then sticking around is probably a good idea, because where we are going from here is stranger than anything yet. This whole channel really only exists because enough curious people decided to stay in the room and keep asking. So if this is your kind of rabbit hole, hit subscribe and let's keep going down it together. Now, you might stop me here and say, fine, but you're cherry picking. You're showing me geniuses and savants, the rare freaks of perception. Of course, math looks magical when you only point the camera at the people who are best at it. Show me the order somewhere it has no business being. Show me order in pure noise. Fair. Let's do exactly that. In 1975, a physicist named Mitchell Feigenbaum was sitting with a programmable calculator, watching systems fall apart. Specifically, he was watching the way orderly systems slide into chaos. A dripping faucet speeding up until the drips go random, a population of animals booming and crashing, a fluid breaking into turbulence, the rhythm of a beating heart losing its grip. Completely unrelated phenomena, and as each of them tipped from order into chaos, Feigenbaum kept seeing the same number show up in the math. The same constant, over and over, in systems that have absolutely nothing to do with one another. One number, hiding in the doorway between order and chaos. The same in the faucet and the heartbeat and the swarm. Or go back to a Belgian named Adolphe Quetelet in the 1800s. He collected measurements, thousands and thousands of them. The chest sizes of soldiers, the heights of conscripts. And every time, the same curve emerged out of the data, that smooth, symmetrical bell. Then he started measuring things that had no business being orderly at all. He looked at human moral behavior, crime rates, marriage rates, the propensity to do this or that, and found the same curve there too. And then he got the chill, because he realized he had seen that exact curve somewhere before. The astronomers had been using it. It was the curve they used to describe the errors in their telescope observations of the stars. One law, one shape, binding the distant stars, the human body, and human behavior, which is supposed to be the most chaotic, free, unpredictable thing we know. Or take the prime numbers themselves, the twins' favorite playground.
For centuries, the primes have looked like the very definition of randomness. They scatter across the number line, with no pattern anyone could find, no formula to predict the next one. Then in 1963, a mathematician named Stanislav Ulam got bored in a dull meeting and started doodling. He wrote the whole numbers in a spiral, winding outward from the center, and on a whim, he circled all the primes. And the primes did not scatter. They fell, unmistakably, along diagonal lines. Faint, ghostly diagonals running through what was supposed to be pure noise. Nobody fully understands why to this day, but there it was, a hidden grain in the wood of the numbers, visible the instant somebody happened to look at them the right way. Or here's the one I love most. A country fair in England, 1907. There's a competition. Guess the weight of an ox. And 800 or so people pay to enter a guess. Francis Galton, a statistician with a dim view of the common man, collected all 787 valid tickets afterward, fully expecting to prove that the crowd was a herd of fools. He averaged their guesses, and the average of all those amateurs, butchers, and clerks, and farmhands, and people who had never seen an ox up close was off by less than 1%. Pure noise summed together became signal. Hundreds of wrong answers added up to a nearly perfect one. And by the way, that is why a jury of 12 ordinary people can outperform a single expert. It is why a market can price a thing no individual understands.
It is, in a strange way, the quiet mathematical justification for democracy itself. Order rising out of 1,000 individual mistakes. Which should unsettle you a little, if you've ever assumed crowds are just stupid. So the order is in the genius, and in the savant, and in the falling rock, and in the music. And now it's in the chaos too, in the static, in the noise, in the dumb crowd at a county fair. At some point, you have to stop calling this a coincidence, because in science, coincidence is just the word we use when our theory is wrong. So here is the turn. This is the part where the whole thing quietly rotates, and the video you thought you were watching becomes a different video. Everything I've shown you so far rests on a single unexamined assumption. The assumption is that there are two things. Over here, mathematics, abstract, made of symbols, living in our heads and on our paper. And over there, physical reality, solid, made of stuff out in the world.
And the entire mystery, the whole unreasonable effectiveness business, is about the baffling bridge between them. How does the stuff in our heads describe the stuff in the world so perfectly? Tegmark's move, the one that nearly ended his career, the one that earned him that threatening email, is to ask whether there are really two things at all. Watch what happens to the miracle when you let go of that assumption. The effectiveness of mathematics feels like a miracle only because we insist that math and physics are two different subjects sitting on opposite sides of a chasm. But suppose a mathematical structure describes your physical reality not approximately, not pretty well, but perfectly. Every property, every relationship, every last detail with nothing left over. If that's the case, then ask yourself honestly, in what meaningful sense are they two different things? If the description and the thing it describes match at every single point with no gap anywhere, then there is no gap. They are the same structure seen from two angles. Reality doesn't follow the equations. Reality doesn't obey the math the way a citizen obeys a law that exists separately from him. Reality is the mathematics. And we, the twins, Ramanujan, you, me, are patterns inside it. If that idea makes you flinch, you're in excellent company, and not everyone goes all the way with Tegmark. Roger Penrose, one of the greatest living mathematical physicists, stops a step short. But where he stops is almost more unsettling. Penrose is a confessed Platonist. He believes the mathematical truths are real, genuinely real, existing in their own timeless realm, more permanent than any physical object, and that what mathematicians do is not invent, but explore, like cartographers mapping a continent that was already there before any of them were born.
The square root of 2 was true before Hippasus drowned for it. It will be true after our sun burns out. Penrose draws 3 worlds: the physical world, the mental world of our conscious experience, and the Platonic world of mathematical truth, and points out the genuine scandal. Each one seems to emerge mysteriously out of a tiny piece of the next, in a loop nobody can close. The whole of physical reality runs on a sliver of the mathematical world. Our entire mind emerges from a sliver of the physical, and mathematics is grasped by a sliver of the mind. 3 worlds chasing each other's tails, and no one can say which is the ground floor. Tegmark just takes the final step Penrose won't. He collapses the 3 into one and says, there is only the mathematics, and the physical and the mental are what certain mathematical structures feel like from the inside. And this is the moment where, if you rewind everything you've just heard, it stops being a list of curiosities. The savant who could see the landscape of numbers. The clerk who pulled physics out of a dream. The order hiding in the rock and the crowd and the noise. None of that was a collection of fun facts. It was evidence. It was all pointing the entire time at one outrageous idea that we were not yet ready to name. And once you accept that idea, once you take seriously that reality is a mathematical structure, something extraordinary happens. The multiverse stops being a wild theory you're free to dismiss. It becomes a prediction, something the math forces on you. The way general relativity forced black holes on Einstein. And it doesn't force one multiverse on you, it forces 4. Let me take them one at a time. They get worse. The first one is almost gentle. It comes straight out of the leading model of how the universe began. A model called eternal inflation, which most working cosmologists treat as the frontrunner. And that model predicts that space is not merely big,
It is infinite. Genuinely, actually infinite, in every direction, forever. Now hold that next to a simple fact. There are only so many ways to arrange the matter inside a region the size of our observable universe. A staggering number of ways, but a finite number. Tegmark runs the figure. At most, around 10 to the power of 10 to the power of 118 distinguishable arrangements. Don't try to picture that number. You can't. No one can. Just hold on to the one thing that matters about it. It is finite. And a finite number of possible arrangements scattered across a genuinely infinite space means one thing with cold, unavoidable certainty. Repetition. If you only have so many ways to build a region of space, and you have infinite space to build them in, then every possible arrangement doesn't merely get a chance to happen, it happens.
infinitely often.
So out there. And I want you to actually try to feel the next sentence, rather than just process it. Somewhere around 10 to the 10 to the 118 meters away, there is a planet identical to Earth, in an identical solar system, in an identical galaxy. And on that planet, there is a person identical to you who has lived your exact life, who has thought your exact thoughts, who has the same scar in the same place and the same song stuck in their head, and who is right now, in this precise instant, reaching the end of this exact sentence. That is not mysticism. There is no spirituality in it anywhere. It is arithmetic. Simple arithmetic applied to an infinite cosmos. And the only reason it feels insane is something Tegmark points out, and that I think is genuinely humbling. Evolution gave our ancestors intuition for exactly the slice of reality they needed in order to survive on a savanna. For medium-sized objects moving at medium speeds over medium distances. It did not equip us to feel infinity.
The universe was simply never under any obligation to be intuitive to a primate. That's level 1. Level 2 is where the unease starts. Because eternal inflation doesn't just make space infinite. It makes bubbles. Pockets of space inflating and pinching off endlessly. A foam of universes. And here is the part that should bother you. Those bubbles can have different physical constants, different settings on the dials of reality. And our settings, the dials in our bubble, look fine-tuned to a degree that ought to be impossible. The masses of the fundamental particles, when you run them through a statistical test, look random, as though they'd been thrown like darts at a board. The strength of dark energy, the thing pushing the universe apart, had to be tuned to something like 120 decimal places for galaxies and stars to be able to form at all. A hair more, and everything flies apart before a single star ignites.
A hair less, and it all collapses back. Nudge the electromagnetic force by about 4%, and the sun cannot burn the way it burns. The whole thing is balanced on a knife edge so fine it makes you dizzy. There are only 3 ways to explain that. Only 3. Number 1, it's a coincidence, a fluke. We just got incredibly lucky. But you already know what I think of coincidence. It's the word we reach for when the theory has failed. Number 2, somebody set the dials. A designer. Which is a perfectly respectable thing to believe, but as physics, it explains nothing. It just relocates the mystery and hands you a bigger one. Number 3. There are vast numbers of bubble universes, each with its dials set differently. The overwhelming majority of them dead, sterile, stillborn, lasting an instant or never forming a single atom. And we, necessarily, find ourselves in one of the extraordinarily rare ones where the dials happened to permit the existence of beings who could grow up and look at the dials and wonder why they're set this way. That's level 2. We see the fine-tuning not because someone arranged it, but because the unlucky universes have no one in them to notice. Level 3. This is the one I need to slow down for, because it hides inside a true story, and the story is one of the most important things that has ever happened to you, even though you have almost certainly never heard the man's name. Just after midnight on the 26th of September, 1983, in a secret bunker outside Moscow, alarms began to scream. The Soviet early warning system was reporting that the United States had launched nuclear missiles.
The screen said the launch was real. The system rated its own confidence at the maximum. The officer on duty that night was a lieutenant colonel named Stanislav Petrov, and his job, by the book, was simple and absolute. Confirm the attack and pass the warning up the chain of command. And everyone in that bunker understood where that chain very probably ended. In a full retaliatory strike. In the launch of Soviet missiles. In the end of the world that was, at that moment, sitting on a hair trigger between two terrified superpowers. He had minutes. He later said his legs gave out under him, and Petrov, with no good reason he could point to, with the machine shouting at him that it was real, decided it was a false alarm. And here is the thing. It wasn't a coin flip. A piece of him reasoned it through in those few minutes. The screen showed only a handful of missiles. 5.
And Petrov thought, that's wrong. If the Americans were really starting a war, they wouldn't send 5. They would send everything at once. Hundreds of warheads, an overwhelming first strike designed to leave nothing standing. 5 missiles made no military sense. It felt to him like an error. But feeling is not proof, and the rules did not care about his feelings. And the clock was running, and the most powerful army on the planet was waiting on his word. He guessed. He reported it as a malfunction, and he held his breath. And he was right. It turned out that sunlight had glinted off the tops of high-altitude clouds at just the wrong angle and fooled a Soviet satellite into seeing missile plumes that were never there. For this, for personally preventing a nuclear war, Petrov received no medal, no parade, nothing. He was quietly reprimanded for not filling in the logbook properly during the incident, and he went home, and the world never learned his name until decades later.
Now here is the turn of the knife. The thought false alarm did not come from nowhere. It happened in Petrov's brain, and a brain runs on physical events, on atoms moving, on calcium ions crossing the gap between one neuron and the next, triggering the cells that carried that thought. And a calcium atom is a quantum object. It does not have one definite fixed position. It could have been, in the most literal physical sense, somewhere slightly different. And according to the many worlds interpretation of quantum mechanics, when a quantum event like that resolves, the universe does not pick one outcome and discard the rest. It splits. Every outcome happens, each in its own branch. Which means that right now, running in parallel to the world you are sitting in, there is a world where that atom landed a hair differently, where the neuron fired differently, where Petrov decided the attack was real, where he picked up the phone, and where the war began. Schrodinger's famous cat, alive and dead at once, until you look. Except the box is the entire planet, and we are all the cat. And the only reason you are here to hear this is that in our branch, one exhausted man guessed right. Many Worlds is level 3. It came from a physicist named Hugh Everett, and for a long time it was treated as a fringe embarrassment. It is not fringe anymore. In an informal poll of physicists back in the late 1990s, the majority still favored the old, comfortable interpretation, the one where looking somehow makes reality choose. At a later gathering at Harvard, when the same kind of question was put to the room, not a single physicist backed the old view. 0. The largest group had moved to many worlds. The dangerous idea is quietly becoming the consensus. And there is a personal consequence buried in here, and I'm going to handle it carefully, because it's the kind of idea that can be misused.
If the universe truly splits at every quantum event, then for any moment in which you might die, There exists a branch in which the quantum dice fell the other way, and you didn't. And here's the unnerving part. You can never experience